Hi students, we just want to echo back to some of the data analysis that we discussed during the lab session that we had this afternoon. And this is regarding chemical kinetics, determine the order and effect of concentration rate of a chemical reaction. So what is important here? What are we supposed to take note when you start working out this table during the course of the entire data analysis? So the reaction has already been given here, and what we simply want to focus on here are the values and the calculations that we're supposed to take note of. So we should understand that the volumes of solution A were given and the volumes of solution B were given. And what we're expected to find were the moles of the potassium iodide as well as the concentration of the potassium iodide. So we're supposed to get this value here, that value there, inclusive these other values, the moles, the moles, the moles. So now, one thing that we're supposed to understand from here is that for the first part of the reaction, we only had the volume of solution A, which was 5 moles. And then when you get back to lab manual, you will discover to say we're given the mass of solution A to be 2.14 grams. So this 2.14 grams was given as the mass of the potassium iodide per liter. So meaning from this we can find out what were the initial concentrations and what were the initial number of moles before dilution. And when I say before dilution, I mean no distilled water was added to solution A. So you can see that from 5 mils of this, there was zero distilled water, meaning that we didn't have any distilled water in the solution. Then we would want to find out what are the concentrations after adding zero point 0.5 mils of distilled water, and what are the number of moles after adding zero point 0.5 mils of distilled water to solution A. So what are we supposed to take note here? We know that number of moles is given by mass divide the molar mass. The mass that has been given here is 2.14 grams. Then divide the molar mass of the potassium iodide, which is going to give us 214 grams per mole. You're going to get 0.01 moles. This 0.01 moles, these are the moles of the potassium iodide before a dilution. So at 5, before dilution, yes. So now what are these moles at 5 moles? So what do? Concentration is given by number of moles divide the volume. How do we get the concentration? Concentration is given by what? There's number of moles divide the volume. The number of moles we found as 0.01, and this has given us per liter. So the concentration that we had initially was 0.01 molar. So now we want to find out what were the moles at 5 cubic centimeters or at 5 moles. So the constant concentrations that we have here is 0.01, which is equal to the number of moles divide the volume of 5. Now we want to convert this to liters. So this becomes 5 times 10 to the power negative 3. So 5 times 10 to the power negative 3, you multiply that, you can find out the exact values you're going to get here. So when you get this number of moles, these will be the number of moles for this particular point here at 5. How about the number of moles at 4.5? Okay, so about 4.5, there was a dilution here. We had 0.5 mils of distilled water. You still do the same thing. This comes concentration is equal to number of moles divide volume. What were the initial number of moles? 0.01. The concentration is 0.01. This comes number of moles divide the volume. So at what volume did we have? We had a volume of 4.5. So what were the moles? We're basically looking for the number of moles. So again, you calculate, but remember that this 4.5 has to be taken into liters. So this becomes 10 to the power negative 3. So therefore, this becomes number of moles is equal to 0.01 times 4.5 times 10 to the power negative 3. When you find this value, you're going to get the number of moles at 4.5. Equally, you do the same. The only thing that is going to change here are the number of the volume. So this becomes 4.0 cubic centimeters, or this becomes 4 mils, but this has to be taken into liters. Again, at 3.5, we do the same. 3.0, you do the same. 2.5, you do the same. 2.0, the same. 1.5, and lastly 1.0. Now, the biggest question here is, after getting the moles of the potassium iodide, how do you get the concentration? Nothing so difficult here. We're going to relate the volumes and the number of concentrations. So we're simply going to say C1 multiplied by V1 will be equal to C2 multiplied by V2. The initial volume that we had was 0.01 by a volume of what? It's 5 liters, which will be equal to the volume of C2 we're trying to find out after dilution. So after dilution we're at 4.5, then this 4.5 you added 0.5 mils of distilled water. So this is just going to give us, this is 4.5 plus 0.5, which is just going to give us 5. So this is 0.01, this is 5 times 10 to the power negative 3, because this has to be taken in 2 liters. This also equal to C2. 4.5 plus 0.5 is also going to give us 5. So this is 5 times 10 to the power negative 3. So we'll divide throughout. What we're going to get is the value of C2. Okay, so this becomes the concentration after dilution. But you'll see that the concentration here will not even change because no distilled water was added. So when you come back here, what is going to change is the volume. To find out the number of the concentration here, you do the same. C1 V1 is equal to C2 V2. The concentration 0.01. The volume, this is 4.5 times 10 to the power negative 3, because we've now moved from 5 to 4.5, is equal to, we're looking for C2 after dilution times the V2 now. What was the dilution here? We got distilled water of 0.5 plus the 4.5 mils of the distilled water. So that you're trying to convert this to liters, so you're going to multiply this by 10 to the power negative 3. What are you simply going to find? The concentration, which is C2. So you basically do the same thing for 4.0, 3.5, 3.0, and the rest of the solutions of A. And then you keep on adding until you find out what were the concentrations after dilution. The reaction time now, how do you record that? When you get back to the session that we had, and I encourage you to watch the entire session that we had for the lab session, you discover to say the reaction time is found by the time it takes when we mixed the reaction of A with the reaction of B. So we had two reactions. There was reaction A and there was sample B. So this is A, this is B. So at the time when A was mixed to B, the stopper, the time started. And then later on, when the time started, the time stop was at a point when we saw a color change. All right. So now that is the time we're going to record here. So the time will be recorded when you get back to your lab session. They're going to record these times. Then you just come and find the inverse of that time. The time you found, 1 divide that time. Here, 1 divide that time. Then you come and plot concentration, divide that time. Then you find the proper graph that will simply describe the entire thing. So this is how you're supposed to work out the data analysis. Actually very simple and straightforward. If there's anything that you're finding very difficult to understand, please reach out to the Pomoroka Movement Group.